Apologies for the loss of stream connection on the last stream. We were streaming through Wi-Fi, and now we're streaming through cellular data service. So we'll see how that works. Okay, so we're back, and Cameron, you were telling me. So what we're doing, we're replicating the simple version of I'll call it the introduction version of the Bruce DePalma N machine, which is really just, the idea is to spin a magnet. It could be a speaker magnet, or it can be a lot of powerful magnets, but you spin them really fast, and then you read the center shaft, the metal shaft in the center. So one of the readings will be from the shaft, and then the other reading will be from the outer edge of the magnet. We noticed on this magnet that it was not centered, because this is not made to be spun, so it was moving. So we're thinking we can maybe cut some of the hose on one side. This side was like a 1/4 inch higher, and Cameron suggests maybe drilling out 1/8, which is half of a quarter, and drilling out 1/8 holes on this side, the side that's high, and that would allow the shaft to move that direction and hopefully center or give more of a centering to the spinning. Okay, so if you want to see how off balance it was, see the first video, and hopefully that video was working well enough that you could see that, and then you can compare that to what we're going to see after we drill this and put it back on. Cameron, may I have the honors of drilling?
Oh, of course.
Thank you so much.
There you go.
Thank you. Okay, and Cameron, let's talk about drilling. Oh, but you were saying something.
Oh yeah, one of my thoughts, and
Yes.
I usually will have a couple different approaches for doing something, so it doesn't mean this is a better idea, it's just a different idea. If we were to press all of these rubber pieces out and just restart, and call this outer ring number 1, take outer ring number 1 and cut it into a C shape or a U shape with the open part directly aiming at this being the high side, and then we just start jamming the rest in, it would scoot it over there as well.
Cameron, I'm having trouble visualizing what you just said. What do you mean cut into a C or a U? Cut what?
Okay, we've got this piece of tubing here. Let's say this is the outermost piece of tubing. Cut here and here. Here, can I cut this one? And just, here, I'll show you. I'll just trim, since it's bicycle tube, we'll trim a piece and it won't kill anybody. So, pretend this is the outermost piece. Do this with the outermost piece, so it's that shape, and then start jamming the rest in.
But that outer piece is greater than a 1/4 inch in thickness.
That's a good point. Yeah, it would have to be with maybe the second piece, if that were more like a 1/4 inch of a piece. Yeah. In any case, I think drilling it will be a good start, and we can always replicate what we did, because we still have more hose pieces, right?
Yeah.
So if we ruin this now, we can still recreate this again another way.
Okay.
We won't be out of supplies.
Okay.
So I think it's worth a try.
Do you feel that we should do what you just thought of now, or do you like the drilling idea? What do you feel?
I like the drilling idea, and also since you're the one who pushed these in, only you know how tough it was getting them in, and maybe you'd have an idea of getting them out. I didn't do it, so I didn't get a physical feeling of how tough it was. So maybe just try it this way, and we can always redo it again.
Sure.
If it has to happen, because it looked like they shoved in with a lot of force to where you had to use lubricant at the end. And,
Yeah, I used my entire body weight to push those in.
I say we drill it then and see how that goes.
Okay. Okay, everyone, thank you for joining the stream, and thank you for watching our video. And we're just sharing our experience and our interest in continuing to learn about the universe we live in by just moving magnets around, moving electricity around, and seeing the different results that we can produce with that. And there's a lot of people that have come before us that have shared their knowledge and their experience of with electricity and magnets and different ways of understanding and relating to the place that we live, which I'll call home. So, okay, so you said this is the high side, and it's a 1/4 inch. This is a 1/4 inch taller than the highest point, than this side, I guess to say. Quarter of an inch taller, so we're gonna cut an eighth of an inch out. And I'm thinking, now, whatever you thought of with hose, cutting the hose, we can apply to the drilling. So are you thinking like literally like 1, 2, 3, 4, 5, 6 holes? Is that what you're thinking? Like,
I mean, at first I thought maybe just one hole, but I don't think one hole's good. I think if we did like, from my experience, you want to do a whole distance away from another one. So I'd have one in the center. I'd have one out here that's a whole distance away, and I've had one that spaces a whole distance away from here. And once you drill this one, and this one, then you can turn it from side to side, and you can break through the holes. Does that make sense?
it does. But you know what I'm thinking right now? Because I know, here's the thing. I think it's going to be really hard to drill into this hose. And I think it might be equal to just taking all this out and cutting the piece of hose out, but that would be less messy and might even be a little easier. I'm leaning toward your idea that you thought of.
The taking it out one or the drilling it one?
The taking it out. I'm leaning toward that. I want to see how hard it is to push this hose out, though.
Whatever you want.
What are your thoughts?
I think since we're set up to just drill it right now, we can see it. But then once you drill it, we're not done. Once you drill it, then we're putting it back on
That's
here
right.
to see how it works. So that's a bunch of work again.
Yep.
So
And I think cutting hose out gives us a very specific measurement difference.
Yeah. Okay.
Whereas drilling, look, between the holes, because you're right, I agree with you that we can't just drill a bunch of holes next to each other. It's not going to work.
Yeah.
It's not going to even drill correctly.
Yeah.
We have to give a space, but I don't think we're going to be able to get in order for it to collapse an eighth of an inch is what we need. We're going to have to use a much bigger drill bit. We're going to have to use a big drill bit to take a lot out for this to give that much. This hose is very strong, and we pressed it in there. It's squeezed in there. It's pressed in.
The fact that it's pressed in hard makes me want to try it this way since it's in place, because it feels like a solid rubber tire. I mean, it doesn't even seem like it's multiple pieces. It feels like Michelin built it.
I like your reasoning, and I'm willing to go forward with this idea.
Let's do it. I say we do it, and then we take our medicine.
But
if it doesn't work, we've got to redo it.
What does take our medicine mean?
Take our medicine means do work again. We messed it up.
As long as it's organic.
It'll be organic.
Okay.
Rubber tires, rubber hoses, it all comes from dinosaurs, therefore it's organic.
Okay. Well, if it came from dinosaurs, it also comes from us. We're not made much different than a dinosaur.
Carbon-based.
Yeah, so it's powered by humans dying as well as dinosaurs dying. And a lot of humans die. I think 100,000 is it 100,000 humans a day die or something? I looked it up.
You could do an equation and just take how many people are on the planet and the lifespan, and you do some division, and I think you probably figure it out pretty quick.
It's all on Google already, though. I mean, people have already figured it out. I think it's like 100,000 or 150,000 people pass away every day just from the process of aging. That was actually, I think, pointed out by I can't think of his name right now, but it's
worldwide, though, right?
Reversing aging. Yeah, it's worldwide.
Yeah, that makes sense.
It's the research being done on reversing aging.
Okay. There's got to be some number, and it's always going to sound macabre. So
are you comfortable with using?
What's
are you
that?
comfortable with using this size drill bit, or should we use a bigger one?
Normally, I start with smaller sizes, and then I move up. So to me, that's kind of a medium size, and I think it's okay to start there.
Okay. Do you want to be in charge of the framing? It looks like this is showing in the shot. And which hose should I drill into it?
I would drill on that side of the red. I would try not to cut the red because the red is a unique piece. Folks at home, this is the red, and the red is our centerpiece. So I would say anything right next to the red, but not the red itself. And the framing's good. If you angle it from this side more, the framing was sitting at the top of the drill a second ago, but you know, it is what it is with that. But
I remember
generally the framing's good.
I remember the man's name that's researching this. One of the lead researchers, it's Aubrey DeGray. DeGray. He's on YouTube. He has a website too. I think it's called sens.org. SENS.org. That's reversing aging, but that's where I learned about the statistics about how many people pass away each day just from the aging process. You know? So he's like, let's reverse aging or let's pause aging. You know, like he's researching on that. There's a lot of research being done on it. It's really interesting. Okay, so here we go. Let's this one, right?
Yep, right there.
Now I don't have a way of knowing if I'm going straight or not, really.
Instinct. It looks pretty good to me. And
I don't want to drill into the cement, so let's make sure we're up a little bit.
Since it's turning to dust, you know, I would say that's a good sign. You're not through, so
let's hold it at an angle. Let's hold it this way then.
Like so.
There we go. As long as they don't drill through your foot.
Right there.
Right there.
Yeah,
right there. It's taking the chunk out.
Well, we wanted chunks out, so yeah, it might not be the worst.
I'll just go like right here too.
Sure.
Here. I can also go like this.
Yeah.
Should I do that?
Holes, it might clean it out of it. Oh, there you go. You walked it through, so now you made the channel we were talking about.
Wow.
And you can see those chunks.
Yeah, that's going to make a significant, I think. It can make a significant difference.
Yeah, we'll see. So next step is to stick it onto the shaft?
I'm wondering, because we definitely did something. I mean, that should be a noticeable difference. I don't know. It could help us to know where we are. It's not that easy to get it on and off, though. Yeah, let me go from this side too.
Let me go from this side too. Try it through this side so it's kind of like equal. We don't have a line over here, so if we were smart, we would redraw that line. Let me do what we should do, which is yo, bring the line over, so that we know where we're centered. You know.
Yeah.
Okay.
Thanks. That's it? That's our center?
Yeah.
Okay.
Onto the shaft?
Yeah. So you want to know what we're doing? You want to know what we're doing?
Want to show you something?
You want me to show you what we're doing?
Yeah, we did
This is a speaker magnet from a speaker.
Yeah.
And when you spin it, it takes basically energy that's just around us. And the idea is, I think, from the way I understand it, is it kind of directs it through this, so that you can, and your energy comes from the shaft, which will be here, and this outer area. So if there's some way that we can apply this to the scooter, maybe it can run some lights and give us a little more range. That's the idea.
I want to run my lights.
Yeah, Cameron wants his lights working.
Lights. Joseph wants his range.
I want my range, but we both want lights and range, so we're thinking that this could work out.
This side, correct?
This could help us. We were doing it before.
Okay,
what do you want to change that? What do you think?
I like it. I say we do it.
Well, hang on. Because if we turn it around, I don't know if that'll let me grab this with the channel locks to make it easier. Or we did it pretty well last time. But look, if I turn this around, is there room for that? No, there's not, is there?
I'm just thinking because they were barely threads.
We're already barely last time.
Yeah,
Okay.
they were barely.
So let's go ahead and let's clean out this area.
Yeah, okay, that's a good idea.
Okay, guys.
Cool. You going to study?
No, not yet.
Okay. I don't know how to get that cleaned out. Do we have some way? You got an idea? Can you get that through there?
Just
Well, it'll
pull
probably
on
push.
it.
It'll probably push through. Or,
Oh yeah, it'll push through. Yeah.
like last time. It pushed through last
Yeah,
time.
it'll push
Okay, so you're comfortable at this point in time trying this again, like
I
putting
think
this all
so.
together?
Yeah, I say we screw it on. I'll try to get it on there, and then you can rotate that shaft maybe to get it. I think we were doing that. We're
Yeah.
I don't know.
The WD-40 makes everything easier to. Okay, okay, that's holding itself, I guess. This helps everything slide easier. It'd be really nice to be able to spin this like it, at least 100,000 RPMs, or not this, but just spin a magnet at like 100,000 RPMs, or something, a high number.
What is it that we have or that exists that spins that fast? Is there anything we have access to?
Oh, the natural experiment, right?
Yeah, it's always trying to just use it where it already just is, Where is that? That there is some. What goes 100,000 RPM?
Well, they have the little small motors that spin.
Look, this is going on great.
But we're getting better. We're learning more about this. About how to
And-
make. We've done this once earlier in the first video. Or no, I don't know if we streamed that, putting it on. No.
We did not. Well, I don't know. I don't think we did.
I don't think we streamed putting it together. So now you get to see how we originally. Now you have to push. You have to push now.
It's got threads on it.
On this side, but the other side, it's mostly not threaded. Oh, but if it's ready, if the threads, I can't. Oh no, I can do it. Yeah, sorry. I didn't realize that I can now. Oh, I don't see my gloves. Let me look for my gloves again.
Sure.
I didn't realize I can put the nut on there now.
Mm-hmm. It feels like it's more in balance. It feels like it's not perfectly balanced, but it feels like it's more in balance at this point.
Oh, you mean just by the turning you did?
Just, by my finger where it is,
Wow.
it's no longer quite as
That's
unbalanced.
good. That's
Although it's
good.
still somewhat unbalanced.
Okay. Oh, the other way. Darn, I did it again. Oh, it pulls it out for us.
Yeah,
I like how it just flipped it. Oh, look, it wants to. That's a cool force, isn't it? Go ahead. That's a neat force.
Yeah, that's you just don't expect things to go anywhere but where gravity goes.
Yeah. Okay, so on this one, I think we're spinning this.
Yeah.
Oh, wow, that does seem better.
Oh, that's great. So it may not tear itself apart entirely.
It'd be great if it was like just really close to like exact. Yeah. Thank
Let's
you.
see.
Okay. Keep going.
See, okay, hold and let go. All right.
Thank you. You have a good system going. Cameron, you got the job. You got the job,
Hired.
Cameron. Hired. You're very good.
So let's see. How out of balance is it still? Not as much. And is it out of balance where that line is? It's still high where the line is. So
I want you to be totally in charge of the balancing part. I mean
I think we could go further. I think if we take it off right now,
because it
we
came
could
on, it
go-
went on and off pretty easily, right?
It came off on it. Yeah, it went well, and
I'm gonna plug it in.
oh, okay, yeah, do it for a second
Okay.
to see how bad it looks.
I'm listening. Please continue.
I think that we could make it very balanced based on what we just did. I think
Okay.
we can do that more. But if you want to spin it for a second,
I do want to spin this. Who wants to spin it? Okay, we're gonna spin it. Let's spin the wheel.
VDC.
We're spinning the wheel. Volts DC.
I am.
Let's show everyone up close. So we're set on volts DC.
I'm putting my negative in the center shaft. I'm gonna put my positive out here, and I can hold it like this if you can
If I can
turn
spin
it
this.
on. Do you want to
Okay.
spin it with your hand first and see what it does?
Sure. So let's watch the millivolts. It's reading millivolts. Let's see it go. Let's see if it changes when we spin this. So it's showing a negative, and let's see if we spin it the other way. Yep, showing a positive.
Wow.
And we're just spinning it by hand.
Okay.
So imagine spinning this at 100,000 RPMs or 10,000 RPMs, or at least 3,000 RPMs. Let's go ahead and turn it on. Ready?
let's see what happens. Be ready to turn it off just in case something crazy happens.
Okay. I'll just pulse it.
Now it's got minus on again.
So let's go ahead and change and reverse hands, switch hands. Because we're going to spin in the opposite way I was spinning it by hand. I
Yeah,
think.
that makes sense.
Yeah. So rotation correlates to polarity, right? Right? That's a way of saying it, right? Rotation correlates to polarity.
I'm learning from you.
And I'm learning from my observation of nature, observation of our natural experiments.
So what are we reading on there? Is it volts? Is it millivolts?
Millivolts.
Okay.
Because we need 1,000 RPMs to get... This is a high amperage system, by the way. That's what the research indicates, is that it's producing high amps, but low volts. So to read the amperage, we'd have to put... how could we read amperage? I wonder if we could just short a wire directly to it, you know? And just see the amps of that. Okay, let's try to get a better, more balanced.
Yeah, we can do that.
So how improved are we with the...
I think we kind of improved half. So if we drill about as much as we did last time, maybe that'll be useful. Oh, let's see that tape measure. Is that out here still? Where's
Yeah.
the tape measure gone?
It's right here.
Because what I'm thinking is, now that we have this shaft right here, it'll be easier to see it. See where it's actually centered.
Oh, good. Okay. Yeah,
Um,
sure.
Like,
Good idea. I'll spin this by hand. Or you just tell me what
how
you
do
need.
I see this? I'm
Yeah.
gonna get down low to see if I can tell how much out around it is.
Okay. Yeah, it's gonna keep doing that.
Okay.
Magnetism is a constant force.
We're at like 4 3/8 ish.
Where do you want this? Okay.
I don't know. It's that I'm not getting very much from that angle. But I think if we drill in the same location again, then it'll be what we want.
Okay. So, ready? Let me unplug this. It's unplugged. Okay, it's
yeah.
unplugged. Oh, let me plug the phone back in. Sharing the plug with two different. I'm sharing the plug with the grinder and the phone charger. Okay, go ahead and spin it. And look how nice magnetism is. It just takes things off for you.
Sure does.
It removed the nut and this for us.
Okay, so
Okay.
now if you hold that, we spin this off by itself. Right?
Yeah, and we got to pull it. There's no threads on part of it, so we have to get it to the thread part. Then it'll spin itself off. And let's not let it fall though, because I don't want the magnet to crack. And it'd be imagine using neodymium magnets.
Oh yeah, this would be super strong.
You got it?
There we go.
Yeah, this is just speaker magnet. So okay, some more drilling.
Yeah, I think drill in the same location again, about the same amount, pretty much.
When you say, I could see the hose move toward that area.
Yeah. Yeah.
Okay, how did you hold it up last time?
Oh, let's see. I had something like that.
Oh, okay. And show me where you're thinking about. Do you see how that hole moved though? Do you see that?
Yeah, it's definitely up there. I would try to get right here. Just chop some out in there.
In here?
Even if you get into the red, maybe a little, but just
So
whatever.
in here?
If you're clearing material there, then yeah.
And should I go over this way more too, each side?
I don't think so. I think
Just
like
here?
the width of a dime from the center point of that line.
Oh, so just this area.
Yeah, just there.
Huh. Okay. Well, do I need a bigger drill bit then? Because I can't drill the same holes.
Okay, yeah, let's do that.
I mean, to be able to remove more material, right?
Sure.
And I don't know how much bigger you want to go, but enough to make to where I can grab more. I have bigger drill bits too. Do you want to use a bigger one?
I have some in my car too. If you want, you can go right to it, or just try this. See whichever you want.
What do you think?
I would just use this because it's here, and if it's destroying material, I'd say it's doing something.
Well, let me get my drill bits too.
Okay.
Because I have... Oh, they won't work in this. Let's get bigger ones. Well, what do you think? We don't want to do too much.
Try it right now and just see if it's...
Oh, because it's fairly easy
to... it to dust,
okay.
Then it's making some difference. If it's not, then...
So I'm going in the old holes, right? The old holes, right?
Yeah, basically where you went before, and clear out some more. See, their material is coming out, which means you're doing something correct.
I'm having a really hard time drilling.
Is it loose in there? Like there's empty space?
Yeah. You might have to go wider, like over here.
Yeah, go ahead.
Uh-oh. That's the tube. That's the tube.
There you go.
It took the tube out.
Okay. Let's see what's going on. I think we gotta try it at this point.
Okay, let's see what it's... Yeah, let's try it.
Do you want to try it on here?
Yeah.
Yeah, why not? Why not?
So now it's much looser, but when we tighten it, it's going to compress.
Here's what I think. See how we have these rings? These rings are self-centering rings, okay? Folks at home, see how this is angled up like this? It's supposed to go into something and center it. So the way I see it...
But we don't want it centered, Cameron. We don't want it centered now. Because centered is off.
The centered is off, but do we know that this centered is off? Do we know that these metal things really centered ever? Or were they just being kind of bugged out by all of our center gaskets, our center tubing? If
this metal, if the distance between the inner part of this and the outer edge of this...
No, this is definitely wrong, because up here...
Yeah, exactly.
Okay, no, you're right. We don't want those centered. We specifically can't have those centered. So,
yes.
Okay, all right. We're working in a wiggly world as usual.
All right. So
reminds me of the normal world.
Oh, you know what? Now that it's so loose, though, we may not be able to spin it. We might have to push it on there and not spin it. Because if we spin it, it might spin the inside. But here,
oh yeah, it'll
hold
all
this.
come out and stuff.
But let's see. Let's see.
Oh, we'll try it.
Yeah, we'll see.
We're gonna keep trying till something happens.
Sorry, I'm trying to not get you. Did I get you?
I don't know.
Okay.
Maybe.
Let me spray. Okay, let me spray this. Okay, let me turn it. So ideally we'd have like a super big, right? Like what? Like a, I don't know, like a, how big of a magnet would be the biggest you'd want to go with?
Oh, I guess something we can physically move, because this thing's already getting us out of the boundaries of what we're able to. That washer stick sits on here, and it's almost impossible to take off. So,
okay.
I think I kind of like the multiple magnet idea, because we can, like, this magnet's very heavy and very powerful, in my opinion. If we put that on and then put another one on and put another one on, put another one on, then we're working more safely.
Oh, so you like having a bunch of these next to each other?
Yeah, I see that as a safety thing.
Oh, I like that. That'd be a neat thing to see what that does too.
Now, before you tighten this much, what if we kind of like pretend we're spinning it? What if you take that wrench off for a minute? Let me just look and see where the alignment is, you know? We're side to side weird, but we're up and down really good right now.
Wow.
We're up and down really good. So I want to shove it that way, just like a little bit by wiggling on it, okay?
Cameron, are we both not working on camera today?
I think
the frame was like down, it was low.
Oh no.
Can you help remind me?
I will
Together,
try.
if we
Yeah,
both
I
remind
will
each
try.
other.
I will
Okay.
try.
Sorry about that, everybody, for not paying more attention to the frame. Be careful, because that inside is very loose right now.
Okay, I would say tighten it right now. I feel like if I just push it that way a bit and you tighten it a bit, I don't want to spin it, but just try to tighten it where it is, and then
And I'm going to tighten it by spinning the other side.
Great.
I'm just spinning the other.
Once it gets a tiny bit snug, let's take the wrench off, like now, and then let's, let me just see how it is. Okay, so it's got this sideways thing, which I don't care about. The up and down is what matters.
Yeah, oh wow.
So up and down's getting...
Cameron.
Yeah.
You're hired.
Nice.
You did it again.
It wants to go that way just a wee bit.
You're very good, Cameron, at what you do.
Thank you. Do this.
Yes, sir.
Can you get your foot on here and your foot on here? Because I need some force going down that way before we tighten it some more.
Okay, at the risk of collapsing this machine.
Yes. Yeah, just step on it for a minute.
Like this?
Yeah, just push on it a little.
If I fall, can I fall in it?
Yeah.
Okay. You're softer than the ground.
Yeah, no, we're good. Okay, so now I would say pop off and tighten it, because I feel like we forced it where it's going to be the most balanced right now.
Oh, can we do the thing where you spin that when I tighten this?
Oh, yeah.
Oh, wait. Oh, the center was spinning. I wasn't holding this side. I wasn't holding this side.
Oh, I get it.
Oh, no, let's see if it's even centered still. Let's see. I mean, it's still good? This way, up and down? Not sideways. I mean, I know that's going to self-center.
It's a little off, but it's not off so bad.
All right.
And I don't know how perfect we're really going to get it.
Okay.
So, yeah, do this.
Okay.
All right, let's see what that looks like. Wow, why does this feel worse again?
I wonder if the self-centering
Oh, the
pieces
self-centering
are pulling
made
it back.
Yeah, it uncentered it. It did.
Okay, we
Because
can
the
we can cut
self-centering-
this. We can cut these. We can cut these. We can trim that with the cutters. We can cut that.
There's probably a washer that already exists someplace
Oh, we can just use a washer.
that, is better than putting that.
Or did it spin? Let's check. It might have spun. Remember
I'm
all
not
the
sure
stuff
what
that
you
happened? It might have turned. The parts we cut might have turned. You know what I mean?
Oh, okay, yeah.
Let's see. Hang on. I feel like we're getting better at taking this apart.
Yeah.
So this is all for the purpose of we're trying to balance this thing. That's what we're working on right now, because we see how uneven this is. Seems like there's a great demand. No, the holders still lined up.
It's still where it was.
So it must be
And
these.
I wanted to go here too, but yeah, no. Once
These must be
once
pulling
that
it.
You know what? Let's do this. Let's put it back together. Let's not tighten those as much, because I don't think those being the tightest is going to prevent this from spinning. Once it starts spinning, even if it was a little loose on the shaft, which it's not really, it's still going to spin.
Okay, let me see if I have some washers that might happen to be this size though.
Yeah. Okay.
Right? Let me check. I might have something. And I don't know if you might too. Let me check that.
Not that size. No.
Okay. Okay. Let's see what we have. This one looks close.
Whoa.
How's that?
Yeah, you're on it.
We got it. That's it. First two that we tried,
Great.
and those were the first.
So we just get rid of the big centering rings altogether. Okay, let's see what happens.
I can't believe how perfect that is. It's amazing. And by the way, we've been talking about this. and this has happened with every single project that I've worked on, is things just work. It's amazing. Right? It's amazing.
Yeah, I think if you have the lifestyle where you gather useful items, just the right ones, then going to the parts store isn't even really a part of life, you know, if you live a certain type of life.
Well, I
where
still
you
go to the
save-
parts store all the time.
Yeah, there is parts store, but you don't have to go as much to the parts store if you know what to not throw away.
Well, and it's just amazing how things just, I mean, sometimes I just find something and that's being used the next day. So
Yeah.
I
Same
don't
here.
actually, I try not to collect too much stuff because you can't. There's no room for everything to just have
Yeah,
everything.
it's hard.
Yeah.
So I would say don't get it tight. Let's just spin it and see how it's looking.
That does look better.
It looks better, and what I want to do is I want to find the side where, okay, this is the least close here. I want it to go that way toward my finger right now.
Hang on, show again for the camera because we don't have the
Okay.
wide lens on this phone.
Okay.
So go ahead and show again,
So,
please.
so I've got my thumb here, and I've got my hand braced on the ground, so my thumb is in the same space. And I'm trying to look, I can tell the high side, the high part is right here. But I want to find the low part. Right, this is my low part.
Can you want to mark that?
Yeah, I can mark
Just mark it
that.
with an L.
Yeah,
A line
right
and
here.
a line and then put L for low. Unless you have a better something else you want to say.
Here's the L for low. I want to push this down while we tighten that. So I kind of want to like.
Oh, how about I stand on it?
Yeah. I
and
want
you
to,
tighten
yeah,
it?
Yeah, stand on
But
it and I'll
Cameron,
tighten
okay,
it. Yes.
Cameron.
Yes.
But here's the thing. I'm gonna have to do that, but I have to hold this as well.
Get the vice grip on that sucker. Can you put a
Hang on,
vice grip
can I put my
yeah,
hand on
yeah,
the shoulder?
do that.
I have to balance
Yeah.
on something. I'm holding this.
Yeah. That's great. Oh yeah, that's great. That's pushing it down. That's just what I need.
Go ahead.
Awesome.
Oh gosh. If I fall, can I fall on you?
Yep.
You're softer than the ground, Cameron.
Yep. I'm a lot better than an aloe vera plant to fall on too. It's a wee bit pokey. It's not bad pokey. It's just friendly pokey.
Okay.
I would say you can hop off. And then we can just keep. Let's.
You wanna
spin
peek at the-
it.
you wanna see what it looks like?
Let's spin it. Okay, we've got this side wiggle, which I'm gonna unwiggle.
Hang on.
Oh wow, that's so good.
Oh yeah, because that
That's
side
so
wiggle
good.
will.
The side
Oh, that's
wiggle
great.
doesn't matter much.
Should we
but
do a test? Let's do a test run.
Let me.
Should we
just
spin
I just want to get rid of the side wiggle because that could increase itself. You know.
Okay. Okay.
So I'm gonna go like this. I'm gonna make the side wiggle gone.
I'm getting a little bit overly excited. I apologize.
Yeah, no, that's great.
It's hard not to be excited when you're doing something like this, you know.
I think we're ready to tighten it a bit more.
Oh,
Just make it nice
I have
and
to
tight.
hold this side, otherwise it'll just spin on the inside.
Gotcha. And that might get rid of the side wiggle. Let's see if that made some up and down wiggle. No, the up and down's really good. It's within like
Wow, that's good.
1/16 of an inch.
So just to clarify,
Yeah.
the side wiggle I don't think affects the vibration, up and down vibration. The up and down vibration is how much this moves this way. And so if we don't have much of this movement, we can spin this very fast, and the side wiggle won't affect it at all, right? If I understand correctly.
I agree. And even if we were really going out there, we could use these 3 empty holes to balance it. We could put something heavy.
Watch your hands. I'm gonna plug it in.
Yeah, go ahead.
Okay, plugged in.
We could
Sorry.
put something heavy in one of those holes if we found that we wanted to balance it. Not that we're going
yeah.
to, but I think we can run it now safely.
That's a good idea.
I think it would work. And I think if I have my foot like this, just,
My concern is I don't want, if this comes apart or something, I don't want it cutting you.
fair enough.
That's my thoughts. But you can do it from this side, this way.
Yeah,
Because remember, this is a speaker magnet, and it wasn't originally made to be spun at high RPM. So this is just our first. This is just a first test. Ultimately, we'd like to use, a really big magnet, as big as we can.
I can be here.
As big as we can carry and move around. And Cameron was talking about using a lot of them side by side. Right, Cameron? You see? Okay. So those are other options, but we're already happy with the results we saw when we saw that just spinning this by hand was giving us an increase in voltage of millivolts. Increase in millivolts. Okay.
That's looking good.
It is. It's very good, Cameron. You're hired. You got the job, Cameron. Okay, ready?
Ready. And it's not tearing the machine apart like it was before. It's a little off balance, but it's not quite as bad.
Should we try tightening it more? And just see what it
I don't know if
does?
it's going to make a difference to tighten it more. We might try to push on it side to side and get that wiggle out of it, maybe. You can find where, you know, which side to push on, maybe.
Yeah, because it's not, up and down is perfect, isn't it? Wow.
It's not perfect, but it's more perfect.
So the side to side, do you want to be in charge of the side to
Yeah,
side?
let's
Because
see.
you're
I
really
think-
good with the side to side as well.
Balancing.
Because
What
you-
I'm going to do, I'm going to use my technique. I'm going
Okay.
to hold this pen in space, and where this touches it is going to be the high side. And then I'm going to shove on that. Okay? Boom. Okay. So now that I've done that, right here, there's a line all the way from here to here. So I'm going to take this and I'm going to go bip. See what happens. Let's try it again with pen at a different spot. Wow, but I think it's better, you know? It's not
And if
bad.
you need a hammer or something, just tell me.
Alright, so now I've got another line. Pretty much where the first one was, but, you know, yeah, maybe a little wiggle like that, a little bit more tight.
Do it again, it just spun. When you,
Okay.
I have to hold this side. And by the way, Cameron, can I mention how you straightened my rotor on my scooter disc? It was
Yes.
wobbling. My rotor was bending. It was like this. It was wobbling like this. And Cameron did the same process and got the rotor perfectly straight. It's not wobbling at all anymore. So that's why I'm happy that Cameron's,
I'm the balancer.
yeah, very good at that.
The professional
And
balancer.
he's got the job too. He gets the
So,
job. You got the job, Cameron.
I'm saying this is like pretty darn good.
That
It's
looks
within
really
like
good.
a 16th. You know, up and down is about a 16th. Over here, it's good. I say we spin it. And,
Good job,
do you
Cameron.
want to get those leads on it while it's spinning? So that
Very
this is
good
like
work.
our-
Yeah,
I'll
this
put
is
my
very
foot there,
good. Very good job.
leads ready, and we'll- Is there a last thing to say to the folks at home about what we're doing, or they already know?
Oh, so we're spinning a magnet. This is, you can look up Bruce DePalma and machine. Lots of videos on YouTube where he teaches all about the theory and what he's learned about this. Bruce DePalma studied at MIT and Harvard, and also taught, if I understand correctly, also taught at MIT. And he learned that just by spinning a magnet, you can generate a, well, I guess you could say a current. You could generate a electricity. We can generate energy. Well, we're not generating. I don't think we're generating. I think it's flowing from the environment through this. And what I think of right away when I say that is I think of how power transformers work that power our homes. So there's a signal, I'm going to call it. It's from, according to Gerard Morin, I think he calls it a resonance flow that goes to the transformer, and the transformer is where we get our amps and our watts from, and that comes into the transformer. So when I look at this, I think of a power transformer, how our homes are powered. This is what I see visually. I'm just sharing with you what I see. Is, from my understanding, according to how Gerard Morin and many others teach this, a power transformer is getting its signal from the power plant, right? It's coming through the power lines. Is that what you're calling them, power lines? Is that what you call them? The power lines? Just the lines.
Yeah.
So
More high power lines.
yeah, so just the power lines, they're sending a signal to the transformer. The transformer coheres, maybe I could say coheres the energy, to use Russell Anderson's words in reference to this and other inventions. And to learn more about Russell Anderson, look up Limitless Energy from the Vacuum, I think is the name of the video, which is a very good video to help understand more about these things. And so when I think of the power transformer, I think of it as the signal coming in from the power plant, and then the transformer, to me, visually, I see it cohering the ambient energy in the environment, and the indicator that this is the case, the way Gerard Morin explains it, is that there's a very small line sending that signal to the power transformer, a very small wire, but coming out of it is very big wires. So that makes sense just looking at that, and then the theory of what's happening, which you can learn more about by studying Gerard Morin. He has a lot of videos, like around 60 videos, I think, on YouTube. And so the transformer looks like it's cohering the energy from the environment with that signal coming from the power plant, and then it goes into our homes and gives us all the energy we need. And so here I see this magnet rotating as cohering the ambient energy as well. So the energy is all around us, and we're just flowing it through the magnet into our meter or into whatever we need to power. So in this configuration with just one big magnet, it's approximately, and I'm not sure if this one's big enough to produce these results, but Bruce DePalma shares that it's 1.2 volts per 1,000 RPMs, revolutions per minute. So if this is turning 1,000 times, so here's my finger, so that's 1, and then 2, 3, that's an RPM, revolution, that's 1 revolution per minute in 60 seconds, right? So how many times does this turn in 60 seconds? Revolutions per minute. So if you turn this 1,000 times in a minute, that's 1,000 RPMs. And 1,000 RPMs produces 1.2 volts in this configuration. There is high voltage configurations. There's experimenters who have, if I understand correctly, the image I see, and this is the way I understood it, is it looked like it was just a big magnet with machined cuts in it, like this, machined cuts, and having copper inserts in there. And then when you spin that, it's going from copper to magnet, copper to magnet, copper to magnet. And that's...
terminals are connected from magnet and then copper and then magnet and then copper, a whole bunch.
One of them, because the other one's connected to the shaft still.
Yeah, got it.
And that was producing a high voltage. Okay, this way, where it's just all magnet with no interruptions with copper, no copper in here, it's going to produce high amperage, and to get more voltage, you have to spin it faster. So if you spin it at 1,000 RPMs, 1.2 volts from here and here. If you spin it another 1,000 RPMs, you'll get an additional 1.2 volts. This is the theory that Bruce DePalma, the foundation that Bruce DePalma built upon in his research and sharing. So, and he has a website that everyone can study.
How many RPMs is this grinder here?
This runs at 3,450 RPMs, 3,450 RPMs. And should we go ahead and turn it on?
I say so. If you're ready, I'll put my foot on there.
Okay.
You ready?
I hope I wasn't talking too much. Okay. Volts DC. No one's holding the meter though.
Yeah, I'll let you hold it since I'll be back here, so I can't get...
Oh, you know what? I have the meter holder.
Oh yeah, grab the meter holder.
I have the meter holder. New technology, and that's right directly from Cameron's notes. It's Cameron's Joseph's notes
Yes.
that you're going to share with me.
Now they are shared, so now
Oh, thank you, Cameron.
our notes.
Yeah, thank you, Cameron.
Yes.
But you get full credit though.
All right.
So this is our meter holder. It's actually a phone holder. It's actually a phone holder, and we bought it on Amazon. And where do you think we should connect this to? What do you see? What do you think? Connected
Does it fit on here?
to the tripod?
That's what I would do.
That's a good idea. That's it's a very good idea. Let's see if I can. Okay, so is this what you're thinking, like this? Wait, I can probably go to...
if it'll... Oh, maybe the center shaft. Yeah, that looks even better.
That's even better, isn't it? Okay.
Perfect. But you know what? This is the day of balancing. Everything gets balanced just right.
Yeah. Okay, let's see if I can get this in view here, just so we can have a good view of the meter. For everybody here.
I love the addition of that meter. Hey, folks at home, leave a comment if you like the meter in the video. Seriously.
Well, the comments are turned off on this one,
Oh, okay.
but you can give a thumbs up if you like the meter.
Thumbs up if you like the meter. Seriously, I think the meter in the video deserves a thumbs up.
Yeah.
I am thumbs upping it like this.
You got to go over here, this area. This is your area. That's it. That's the thumbs up. No, but it's got to go up.
And another thumbs up.
But it has to go upward. Yeah, like
my
that.
Gosh.
You got it.
Like
you did
yoga.
it.
Yoga giving you guys a thumbs
Yeah,
up.
yeah. That's very good. That's very good. Okay, like I was saying before, in the past, if you have thoughts and ideas to share, please make videos of those, and share your questions and your thoughts in videos. And you can turn comments off, but just share to get that kind of share your imagination, and it's important because everything I'm doing came from watching videos of people sharing their thoughts, and I just want to thank everyone for sharing. Every day is share day.
Also, the shared note. Also, it's not all a video. Some of it's the shared note. The shared note is an influencer. My shared note about the clip idea. I'm joking around.
A share. What is that?
You said your ideas.
Oh, the notes.
Videos.
Oh,
But
notes.
The shared
Okay.
note is another.
Yeah, the
idea
shared
form
note.
that Joseph and share now.
Yeah, that's, and Cameron makes notes he makes a list of notes, and he calls them Joseph notes, right? Joseph notes.
Yeah.
And then there's a list of notes of us, things for us to do. Cameron calls them natural experiments, and things that we can do and experiment and do and testing. And so Cameron just shared those with me today. So this is going to be life-changing. And
Yes.
we're taking this to another level. So anyway, everyone, thank you for being here with us and for sharing your interest in watching this video. Okay, so I'm going to go ahead and let's see what we have here. Should we see what we have? Okay, so let's see. We'll touch these together. It goes to 0. Is this just picking up energy in the air? It's like, when I touch them together, it goes 0, right?
Okay.
And then when I take them, it's -0, it says, which is interesting, right? -0. I take them apart, and it goes to negative, like, it fluctuates, but it's like -0.8, 0.9.
Is it the same 2 feet over, like in
Let's see.
space?
No, it changes. This is
near your phone? Is it near?
when it's near the phone, let's see.
Because I know the phone's doing work right now.
Yeah,
Is
just moving
is
it
the
around
grinder-
space. Just
the
move.
grinder has electricity going through
Yeah.
it. Is that technically sort of doing? Think it's doing work?
I don't know. Let's see. Let's go ahead and get some readings off of our system here. Okay, so I'm in charge of the power, right? Okay.
And yeah, I'm gonna keep out of the spinning motion just in case.
We're not going to be able to take this up very high because it's still vibrating a lot.
Does vibrate. Wow.
But it didn't look like it was. It might just need to be balanced, huh? Right? It might need to be balanced. Okay, well, let's see what we're showing just by having it. So it's off. Let's see. Off and on. So it definitely does change the reading.
Oh yeah, it wants to walk a little.
Well, it's definitely showing. It's definitely showing a difference.
Did it get to volts?
It was staying in millivolts,
Okay.
but it's the amperage. This is a high amperage system in this configuration. So,
I wonder if we can connect like an LED bulb up instead of the meter. Would that? Do you think there's something that would illuminate that you own that we could connect?
oh, like a test light,
yeah.
like a
Yeah,
you test.
light. To me, that
Gosh.
would work. You know.
Yeah, let me see. Let me see if I still. I don't even know if it still works. I just saw one. Okay, well, the thing is, I think this one requires 12 volts. I mean, so
We're
I
not
don't.
getting 12 volts.
No,
so
we're not getting 12 volts. I don't know. I don't think it'll do anything, but
I'm thinking more like I have these. Do I have one with me? I might have a little light that's got an LED bulb in it that's like a 1.5 volt. But even still, we're not getting 1 volt yet. So I'm thinking.
But maybe if the amps are high enough, maybe it'll still work because the watts will be there. But it might require a certain voltage, but we can still try it though.
Yeah.
I mean, you said 1 volts, right? 1 or 2 volts?
Yeah.
That's a lot better than
something that
12.
runs off the little watch battery.
Yeah, this requires 12 volts, so this is...
I think I have some in my bag. I think I have some little.
Well, let's try it.
Yeah. Okay. Let me walk past you here. and
Sure.
I'll-
Oh, it's inside?
Yeah.
Okay.
I think I left it in there. Oh yeah.
I like that. Do you want to show your little case yet? That's neat.
We can do it. Oh, you know what? Look at this. This is 3 1.5, so that's 4.5 volts. I guess I'm just incorrect about what I thought I had. Isn't that 3 times 1.5?
Yeah, that's
So that's
yeah.
gonna. It's. I don't think it's gonna be the right experiment.
Okay.
We want something that's like a volt, like a cheap flashlight from the 70s, you know, that's got a 1.5 volt.
But Cameron, we can still try it though. Let's try it. I still want to try it.
Let's try it. I'm just seeing if I have any other.
We can even try the LED. Let's try everything. Let's try everything.
All right. Well, this is how long it comes with the way that it works, but you know, there's a bolt there
Okay.
to enjoy.
Okay, I'm gonna take off my gloves because I think that
oh
was
my
just.
gosh, the other one is putting batteries in this circuit as well. I know it might be, you know, outrageous to imagine.
No, I won't. We
Put
want to
batteries
try
in
things. We
circuits.
want to try things. Okay, so on this side, can you help me understand what I'm looking at, Cameron?
Yeah,
With this?
I'll give you. Here's another one just to see an intact one. 3 button cell batteries, which are like 1.5 volt in series, and then the switch works by this pushing. These batteries are dead, but this little metal thing connects with this short piece.
You got to go this way.
Okay.
I think the lens is right here on this one.
Oh, gotcha. Okay.
Yeah.
It basically these are dead batteries.
Oops, sorry. Up.
Okay. Here, let me just drop those in.
Okay, right here. This is frame center.
Oh, now I'm seeing it. Okay,
Okay,
wow.
sorry about
yeah,
that.
so we're really tight.
Yeah.
So there are 3 button cell batteries here. They're all dead in this one. When you press this lever down, it connects with the LED bulb, which, you know, this is how it works. There's a little
Well, let's try that.
LED bulb.
Okay, let's try it. Let's try it.
Yeah.
What we'll do is I'll use these connectors off this other LED,
Mm-hmm.
and we'll just we'll connect it to this. Okay.
Oh, nice. Yeah. And then just attach it to that while it's spinning.
Yeah. Now I'll try. Let's try. There's it's 1 or 2 ways, so we'll just try each way.
So you're ready about now?
Can you operate the power for this right now? Are you comfortable doing that? You're
this?
yeah, and I'm just I don't leave it on.
Yeah. Say when.
So right now voltage. Let's just turn the meter off because we're just gonna see if we can power this bulb up. This is a 1.5 volt bulb.
I believe it's 4.5 volts.
Oh wow! So this probably won't light, but we just want to see what it does. Okay. Okay, let me turn the polarity around. I'm just going to change the polarity because
Okay, yeah. It's a good foot massager if you ever want to come try it. It's like a 50-cent foot massager.
Okay, so I just changed the polarity. I changed the wires around. Okay. Oops. Let's try this. This might be a good way to visually see it on the camera. Oh, that's no. Let's see. Maybe right there. I'll just put this in the clamp too. Oops. Okay, Cameron, let's do it again.
Right.
Yeah, but that was like the limits of how fast. I don't want to go.
Yeah, okay.
I'm just. It's kind of direct. I don't want this thing coming apart on me, you know.
Okay.
Oh, I forgot. I could just switch these. I could just switch the polarity here. Go ahead again. Okay. All right, let's try. I think these just require more volts because
That's.
But we just wanted to try since we're here. This is something we would test like off camera, but we're just gonna we're running.
I guess another idea is like a tiny electric motor, like basic 1.5.
Ooh, I like that.
motor.
Okay, let's do this first. Can you turn this so I can reach it better?
Rotate it?
Yeah.
Oh, crap.
You okay?
Yeah, I just don't miss it.
Okay, ready? Okay, go ahead and. Yeah, this needs to spin a lot faster to get these lights going, right? But let's try a little motor like you said.
Cool.
Oh, we'll try one of our little servo motors.
Yeah.
Okay.
Oh, my blue tape I lost. This is my electronics.
Oh, you did?
Yes.
Good.
Done?
Huh? Almost.
Okay, you ready for a foot? Or you're going to get your leads ready, right?
Okay. Yeah. So we're gonna use this motor. This tape is just so you can see if it's turning. See it turn better. I'm gonna put the leads on. Can I set this on the light?
Yeah, sure.
Okay.
It's got that protective film, so.
Okay. So in this case, I think I'll take the meter out because we're not reading. We already saw what power it's doing. Let's see if this will hold our motor though.
Nice.
Oh, it doesn't seem to clamp that well on something this
You
small.
wrap the rag around it. Space it out with the blue rag.
That's true. Good idea.
Everything is our tool. Everything that's next to us is.
That works. You can see the. Okay. Let's see if I could still find where to connect the motor. So this is a 25 volt motor, but it'll start turning at very low power. I think. Did we ever test that? How low it'll go?
I'm not sure.
Okay, well, let's see. That's something we can test.
You ready?
I'm ready. Don't let it go too fast. Just start slow.
Okay.
We can always go faster later. It's vibrating.
Reverse the polarity on your switch. Where you
On this? What?
Switch where you're going to. One in the strap, the other on the other.
Oh, it came off.
Okay.
This needs to be slid back over here. The cords are very short.
Weed whacker.
I think there's a great demand for a balanced magnet
Yeah.
that we could
With
spin.
us.
So what does that do?
It, I'm trying to think how to say this. It basically, the magnet acts like a, would you say like a window, like we let the energy flow through it when it's
Yes.
spinning? Yeah, so when this is spinning, it's like opening the window to letting a breeze in. And the breeze is energy.
It opens the window up by itself with that?
Yeah, to energy flowing. Energy flow. It's just a visual. It's a visual.
Oh,
Yeah, but it's about energy. We can show you on the meter how it makes the meter change.
Oh,
But
okay.
you just spin a magnet. You know, this was discovered by Michael Faraday, and then the work was continued by and brought to a higher, expanded on by Bruce DePalma, who was a student and then a teacher at MIT, and then he studied at Harvard as well.
Cool.
So, okay, ready?
You ready to run it again?
Yeah, ready?
Yeah.
You got it good?
Yeah.
You getting a foot massage?
It's great.
Okay.
I'll leave my 50 cents.
Well, the thing is that we have to spin it fast, and we're not getting it. We're not spinning it fast enough. But we just wanted to try. We're just trying. All right. Okay, let's. Okay, I think we're just about done for today. But let's go ahead and read a voltage again before we wrap up. And we'll just show what's happening when we touch, even at this low speed. Let me go ahead and recenter it, Cameron. Thank you. Okay, you got it?
Yeah.
Okay, you got that good? And I'll hold it with my foot too. Ready?
Yep.
Okay, I'm gonna go ahead and turn it on. So here's our readings right here. I got the meter here. Okay, well, we're not spinning it fast enough. But it seems like there's just energy all around here.
Okay.
Okay.
Cool.
I mean, there is energy all around here.
Indeed.
It's just so much vibration, we can't really spin it fast.
I think that, yeah, we've got sort of the wrong magnet. It's strong, but I think that it's not really built to be spun like that, unfortunately.
Yeah, so what do you think the next step with something like this could be? What do you see right now? Like, because we know we can't have it vibrating like
Here's
this.
the thing.
Yeah.
It has those 3 bolts on it. It has those 3 holes, I should say.
Okay.
And if we take some plywood next time, and we place the magnet on top of plywood, we trace it, we trim the plywood with a sawzall, and then we locate those holes. We make a plywood piece on either side of this, bolt it through the 3 holes, in the center of the plywood, we can figure out the center point of that. We will be able to. We'll take more time, we'll do a better job. I think we could center it on 2 plywood pieces, and then I guess at that point we would realize that the width would be too wide for this. So I wonder if we want to somehow take it out, permanently fill this middle with like epoxy or something, and then re-drill it center.
Mm.
You know what I'm saying?
Yeah, yeah.
Because epoxy is strong.
Yeah.
And if we thought hard enough and tried hard enough, we could center that. You know, it's still, the fact is that this aluminum piece is not centered on this magnet piece, and so no matter what we do to get a center hole, the thing inherently is out of balance.
Yeah.
You know? So if we did that, I don't think we should invest that much time and energy and expense, because it's still going to be that imperfect. So I think we could, just use something cheap, like some wood in there, or epoxy and wood, or because even if you spent the money on the epoxy for that, that's going to add up in dollars. So Maybe we get a chunk of wood in there and epoxy it in on each side.
I mean, I just want to find a magnet that like a neodymium magnet that's maybe a little wider than this and maybe taller, at least 13 inches.
Okay.
That's what Bruce DePalma used, 13 inch. And maybe 3 or 4 inches and find one that's 3 or 4 inches deep, and then spin and have it be perfectly balanced.
Yes.
And then we can just spin it whatever we need to. I mean, we can spin it at 100,000 RPMs.
Can we get a bicycle and turn it upside down and make that a test? What RPM can a bicycle wheel spin up to?
I don't know.
Probably not that many, because a bicycle goes 30 miles an hour, and if your wheel is like, what is it going to be, a 6 feet circumference or something divided by 30? No, that's not going to be thousands of RPMs. I'm thinking something like a bicycle fork, or you know what I mean. An upside down bicycle is a nice test stand. You could spin that and it's held safely. You could attach it to something. We need some kind of good test stand for this where we can spin it. So I think we need to be thinking, what is that test stand that we could find sitting outside right now or tomorrow?
Oh, the natural experiment.
The natural materials. The natural materials stuff you already have. You don't need to buy stuff. Yeah.
Cameron, this makes me think of something, and I want to bring one of the motors in to show what I'm thinking about, okay?
Yeah.
Okay, everyone. Hello. Okay, welcome to True Zero Emissions. Thank you for being here with us and sharing your interest in watching our video. And I just want to show that I was thinking of something, Cameron, and I would like to have your thoughts on this. Oh, Cameron, would you hand me that wrench? I don't want us to slip on that. This is very slippery. This is a slippery wrench here. This one, if you step on this, it's slippery, especially when it's on metal, which it was on the metal ramp. Okay, so this here is what's called an outrunner motor, and it has I mistakenly called the center of the rotor last time. I apologize for that mistake. On this, the rotor's on the outside because it rotates, so that's a rotor. And the stator, which holds still, stator stays, is the coils inside, okay? And this works very well for charging batteries, and when it's hooked up to I think it's called a 3-wave bridge rectifier, which takes these 3 wires and lets you have a positive and negative on the output. So I was using this as a battery charger, and it works very well for that. So in reference to the end machine, or spinning a magnet, whether it be one magnet or many magnets with copper in between, and then getting your reading from that difference, I'll call it a difference between the copper and the magnetic field. That's just the words I'm using right now. But I was thinking, this kind of motor has the magnets on the outside. I mean, it's on the rotor. The magnets are rotating. And I'm thinking to myself, these can spin at a very high RPM. Mm-hmm. You know where I'm going. Tell me what you see. Tell me what you see, Cameron.
Well, isn't that already
kind of what we're doing?
It's already this, but aren't these, are these called phase wires still?
I think so.
Okay.
We can call them that.
These just doing this? But we were using 2 points. I don't know what the third one's. Isn't it already wired for what we're doing? Isn't it?
I don't know. I feel like this spinning really fast. The magnets are spinning. And so how do we access the way this is interacting with the environment it spins in? That's what I'm thinking.
I feel it's these, but what it makes me think of is the homopolar motor, where you have one AA battery, a neodymium magnet on top, a neodymium magnet on the bottom, a coil of copper wire that spins down from top pole to bottom, and once it touches the top and the bottom, it just spins and spins and spins. That's only 2 poles. It's using magnets. I don't know. It's what it makes me think about, even though I can't tell you why. It's what popped up for me. It's because this is 3 wires here. You said, how do we access it? I say it's wired to do it. but we're using only 2 poles here. This is 3. So
But are you saying that's if we spin this with something, or?
if you spin it with something, should it
Or-
not?
Mm-hmm.
Should it not put whatever you call it, power, energy, move energy, shove energy?
Okay. Let's talk
Those
and think
wires.
more about that. I want to understand what you're saying. I feel like there's something there. I don't understand it yet.
Well, if you attach this to power,
Yeah.
and this spins this, so this is a motor, and these are wires. I assume you just have to attach these 2 wires to get this one to spin. Am I right, or am I not right?
You mean to make the motor work?
To make the motor work, yeah.
I haven't tried it with 2. It usually takes 3.
Okay, it takes 3. Okay.
I haven't tried it with 2.
In any case, when this spins,
These are brushless. They're called brushless.
yeah. When this goes
Outrunner.
like that, is it not that you can test these with the test leads, and this makes a voltage change? When you, I'm sorry, I mean,
We can try. We
when I
can.
spin this.
Yeah.
I mean, isn't that what it does?
Well, I guess we have more testing to do. But Cameron, I want to say something. Something's coming up while you're saying this that I want to say to you. And this is very significant, and I don't think we've said this yet in the video. And I apologize for that, because this is very important. One of the really important aspects of the end machine, or spinning a magnet like this, is that when you extract the volts and amps, right? When you extract the volts and amps from this by spinning it very fast, right? 1.2 volts for every 1,000 RPMs. So you multiply the 1.2 times every time you increase from 1,000 to 2,000 to 3,000 RPMs to 4,000 RPMs to 5,000 RPMs. You just add another 1.2 volts. That's if you have one big magnet like this. There's ways to get higher voltage, and from what I've seen and understood, if I understand correctly what I saw, it looked like someone had a magnet that was machined. It had holes cut in it, and then had copper cylinders slid into that, so that when you're reading the voltage and the energy, when you're reading the energy, you're getting a reading from magnet, copper, back and forth, and that switching really fast at high RPM was giving a high voltage. So that's a way of getting high voltage. But what's very important, and this is what I haven't mentioned yet in the video that I recall at least, is that when you draw power from this, it doesn't become harder for the motor to spin this. And that's something that these right now, in the way that I usually use them, when you put a load on it, what I mean, when you are charging something or when you're running a light, it slows down a little bit. So this is an important part, because we're looking at how much energy goes in, how much energy comes out, right? This is what one of the big parts of what we're looking at.
You're making me think this. Forget these wires.
Sure.
If in this model we're connecting, the positive or the negative to the center, the other one to the outside, then in this little, whatever you want to call it, generator, motor, whatever it is,
It's
can't
both.
we just touch this very shaft and this?
Thank you. We need to try that.
That's what it is.
That'll be another video.
That's what it is.
Okay.
Or this,
I like it. I like
That's
this.
what
I
it
like
is.
your thinking, Cameron.
And then, if
Cameron,
yes.
you got the job.
How much does it pay?
Millions.
One burrito a week.
Millions.
Yeah.
Okay, so
What else can we do with this today?
I think
to
we're
power something with it.
yeah. I mean, Earl wants to go on a scooter ride. I think
I'm ready to go on a scooter
we're
ride.
all ready to go on a.
Done with it?
We're still streaming, but we all want to ride scooters.
This is what we need to do. We need to have it on and drop a ping pong ball onto it and see that thing bounce gnarly. I'm not kidding.
Well, Cameron, you want us to film you bunny hopping, but when the light's good
Yes.
on the scooter. You want to do a bunny hop on the scooter over another scooter,
Over a rental scooter.
over another scooter.
But it's going to involve my scooter not having a seat. And today, I'm going for the scooter with a seat. Fit in with my boys. You're going to see you're going to both be so jealous of my scooter seat. Can I show do the folks at home want to see the scooter seat a little bit? matter for them. Maybe another live stream.
Another live stream. Yeah, there
But,
could. That'll be, I think, a special live stream, Cameron.
Okay.
I mean, if you really want to put it in this video, you
No,
can.
I don't think. I think that
Okay.
it works in another one.
Yeah.
You can do scooter technology.
Yeah, this is
later.
end machine energy,
Yeah.
and the other stuff is all like our inspiration, our smiles, our happiness.
Yeah.
And I hope you don't get hurt when you do your bunny hop on a scooter. And I also hope you don't hurt the bird scooter, because we don't want to
Oh,
hurt.
I'm not even. I can
We
bunny
don't.
hop good.
We don't want to hurt the birds.
I don't need to hurt any bird scooter. I can bunny hop right over it.
Okay. Okay, everyone. Well, thank you for being with us here today, and we are very grateful to you for being here with us and for sharing with us your interests just by watching this video, and all the positive things that you do in your life that make you happy, and then sharing your happiness with us as well by watching our videos and by all the things you do. So we'll make many more videos, and we'll keep sharing our questions, and we'll keep discovering questions with you in our live streams. Until next time. Oh, and I have to stop talking about 3 seconds before I stop the stream.
Or else.
Otherwise it takes some of my words off, I think.
Bye, people.
Bye, everyone. See you later. Okay,
Later, dupes.
so count to 3. 1, 2, 3. Okay.
3 and a boom.
Bye-bye.
Oh, dude. I'll show you next.